So that film's got us off to a very, very good start, and we have a programme where we want to explain this project, and I'm starting off by setting the scene in general terms. So we'll have a number of talks this morning, but to put it into context, I want to fall back on the value to the economy of the subsurface in the United Kingdom, and it's really quite remarkable that a sixth of the UK's economy depends on materials which are mined from the subsurface in this country. That is £5 billion worth of mine production, but that £5 billion are essential raw materials that lead their way through to a value of 235 billion of products. And that sector of the economy would stop if we stopped mining in this country. It's mining in a general sense. Now, we can add to that oil and gas, which isn't taken into account in those figures, and then those figures rise commensurately. So the use of the subsurface has an important impact on UK PLC and on our ability to live in the prosperous society which we all enjoy. The other thing that is not often widely discussed is the importance of the subsurface in the global context. And there are two new developments which I'd like to mention to you just as examples of how the subsurface is developing in this country. We have the world's second largest tungsten mine outside China. It recently started producing tungsten ore on the edge of Plymouth, so on the edge of a city. And that mine has gone ahead, capital expenditure to build that mine about £123 million of private money. And then in the North York Moors, some of you will have heard about the York Potash project, which has grown into a project where the plans are to have a mine that will produce more fertiliser than the whole of Canada for 100 years, up to 20 million tonnes. That's £2.5 billion of private money being invested in that. And of course, that's really, really exciting. Coming from Newcastle, it's on my back door, and it's one of the most exciting things that's happened for a long time. These things can only happen if we understand what the impact is of those operations on the subsurface. Those are minerals which are being produced. And then with oil and gas, we still need oil and gas. We don't want to burn oil and gas because we're burning a very valuable raw material when we do that. But the oil and gas sector is in transition. It's important to recognise how active it is in this country with minimum disruption to everyday life for people. But it's also important to recognise that we as people use that. So whenever we are buying and eating food, we're eating material that has come from methane. The nitrogen fertilisers that underpin agriculture require methane as a raw material to make them, not as an energy source, but as a raw material. And every year, 100 million tonnes globally is used for that purpose. That's how the world can support 7 billion people now. Before we started that process, about 30, 40 years ago, we only had to feed 2 to 3 billion people on the planet. So the population that the world has at the present time depends utterly on methane as a raw material. It's also interesting to see how things change as prosperity has changed. So these are just two graphs to show you the way in which minerals are used and have been exploited. Between 1980 and 2013, metals have risen, as you can see, but non-metals, i.e. industrial minerals and construction minerals, have risen far faster. And this we can emphasise if we normalise it to population. So we look at it as a per capita basis. We can see that metal consumption stays about the same as 12% of the minerals, of the materials as raw materials we take from the planet Earth. But industrial minerals and construction minerals have risen from 20 to 30% on a per capita basis. So all of a sudden we're seeing that actually the fuss about metals is there and it's important, but the fuss about non-metals, particularly sand and gravel, and some of you will have seen issues relating to sand and gravel availability, will know that these materials are actually rather important for things we take for granted like roads and houses and so on. So that is something which is rising. We know that in that context that we have to pay attention to the subsurface. We've got the evidence of these new mining activities and other extractive activities that the use of the subsurface in our country is going to increase and continue to do so. So what's really important about this is that we understand these processes, and the Geoenergy Observatories fit into this context. We need to know what happens naturally, but we also need to know what happens as a consequence of perturbation by human activities, and we need to know how they change with time. Do they change rapidly? Do they change slowly? These are all information sources that are required to allow decisions to be made. And it's in that decision-making process that I think that Britain actually leads the world. we see business, government and environmental organisations working together in partnership. There's a particular role for local government here because many of the decisions that relate to planning for mining activities are made at a local government level. And so local government is really in the front line in this respect for making sure that the materials are there to allow housing plans to be and targets to be met and that sort of thing. So we do need to use science to make sure that those decisions are made with the best information. And this is the key point about the UK Geoenergy Observatories. They are going to tell us about how the subsurface interacts on a real-time basis for much of the information that's gathered. They're collecting information and making it publicly available so that people can see what's happening. So the overall outcome of that is that uncertainty is reduced and it allows decisions to be made with much more confidence than might be possible at this point. I've been heavily involved in the design of this project, obviously not as part of BGS, but as part of the academic community. And I have to say that the input from the science community, represented by Britain's universities and by the British Geological Survey, has meant that we've had some wonderful inputs to enable this to go ahead, to get the best possible science outcomes. And it isn't just from the UK. We're calling upon international guidance with this as well. So there's international advice coming in to make sure that what we do attracts the attention of the world and in fact is going to be something which other people elsewhere in the world look upon with some envy. So it is a really important global facility that we're talking about and planning here.